doesn't really bind things together like electromagnetism or the strong force. This force is responsible for causing particles to decay. When a muon turns into an electron, that happens through the weak force. Science says if the weak force wasn't there, they tell us the sun wouldn't fuse hydrogen into helium, and there wouldn't be any so-called matter in the universe. So this is how science sees reality. A lot of electromagnetic fields working together to make your reality. But remember, these are not particles, they say. They are really fields of energy. Everything is a field of energy and not a solid particle. This is what the Standard Model was as of the 3rd of July, 2012. At that point, the only piece missing was the Higgs boson particle. What's the Higgs boson particle? Why is it important? To understand that, ask a deeper question. What does science mean by a particle? Science has made these particles sound like little Lego bricks, like solid points that move around and stick together. That's not in reality. Modern particle physics tells you what particles are. The field of study, particle physics, is badly named. What you're being told are particles are actually fields. Not particles, but fields. Fields. Okay, so from here on, I'm replacing the word particle with field. I've talked about this at least 3 times now on this show right now so that I can help rewire your mind. We are fields of energy and we live in fields of energy. Hold a magnet next to a piece of steel and you feel the effect of a field. A field is something that causes a force to be exerted over a distance where there's nothing physical actually causing that force to be exerted. A magnetic field can be strong near a magnet and grow weaker as you pull the object away. It can be a so-called gravitational field. Every so-called particle has or is an associated field. There is a field for the quarks, the electrons, the neutrinos, and for all of the force particles. The way science sees these particles is like they are tiny ripples moving through these fields. They're small, localized disturbances in these fields. And that's how science thinks of all matter, electrons, quarks. Everything are just little ripples moving through cosmic energy fields that fill all of space everywhere. What is the Higgs field? In the 1960s, when the Standard Model was being put together, it was discovered that if science tried to make the particles in the Standard Model massive, then their theory broke down and gave the science community nonsensical answers. There was a particular problem with the W and Z particles, which emit the weak nuclear force. It was thought by the scientific community that if they existed, then they had to be extremely massive. But if they gave them mass in the theory, then the theory gave nonsensical answers. There had to be some solution to this. And the solution was for science to invent another field. So Peter Higgs said, imagine if there is, throughout the entire universe, an additional cosmic quantum field. And particles we think are massive move through it. They are imbued with mass by this field. For example, the electron, which has a certain mass. What the Higgs mechanism theorizes is that the electron is massless, but by interacting with this cosmic energy field, it acquires the property of mass. Higgs attempted to connect this theory to something that could be experimentally measured. And what he added to his theories was one line that read, if this cosmic energy field that gives mass to all the particles exists, then you should be able to create a ripple or disturbance in it, which would show up as a new particle or field. And that ripple in the Higgs field is what science calls the Higgs boson. So the thing that gives mass to all of the fields we're made of is this field. The Higgs boson is science's proof that this field is out there, and that's why finding it was so important, because the Higgs mechanism, this Higgs process by which the particles get mass, is absolutely fundamental to the Standard Model. It's the keystone. If you take it away, the whole theory falls in on itself. Science was convinced that this field must be out there. That's why finding it was crucial. The Higgs completes the scientific community's standard model of particle physics. This theory is used to explain all of their physics. How a light bulb produces photons, how atoms are fused together inside stars. It's the closest science has to a theory of everything. Now, here is what's hidden in plain sight. The electron has an electric charge and behaves like a magnet. It has a north and south pole and gives off a magnetic field. This is what I believe gravity is. Electromagnetism. You stick to the ground because it has more electrons than you do. You are a smaller magnet, and the ground you stand on has more electrons and magnetizes you to the ground. Physicists use the Standard Model to calculate how strong the electron's magnetism is. They can do this. They do this to absolute fantastic precision with supercomputers by putting the theory into the computer and precisely calculating with a very small uncertainty. Science theoretically predicts and measures accurately to 1 part in a billion. The Standard Model is a stunningly successful theory for them, but not without problems, which motivated the building of the Large Hadron Collider, as well as the discovery of the Higgs, which closed the chapter of 20th century physics. What everyone was actually really after were answers to big unsolved questions that the Standard Model cannot address. Now, there's something called gravitational lensing regarding light from allegedly distant galaxies allegedly traveling toward Earth. Einstein theorized that gravity makes matter move in orbits or curves, and also curves space-time, and causes light to travel in curved paths. Current science would say to you that what's happening is, imagine you have a galaxy that is emitting light, and the Earth's over in another position. And there's something heavy in between the galaxy and the Earth. As the light leaves the galaxy and travels past this heavy object, it's bent by the object's gravity and pulled back toward the Earth again. It acts like a lens, and you see a smeared image of the galaxy across the sky. Science alleges that they can use this lensing effect to work out how much matter there is in the center of a galaxy, because the more gravity, the more mass there is. The more pronounced the gravitational lensing effect will be. But again, I believe it is merely magnetism, and gravity is being called gravity when really it is just magnetism by a higher number of electrons versus a smaller number of electrons. It's magnetism. Gravity is the wrong word, just like particle is the wrong word for field in physics. Science has also found evidence of something called dark matter, which is essentially some kind of invisible substance, which science claims it doesn't know what it is. It allegedly makes up a very large fraction of the universe. Physicists claim that it's far more abundant than the atomic matter that the Standard Model describes. Their evidence of dark matter comes from so-called gravitational lensing and from simulations that science claims to show how the universe formed. Science says that if you want to show how a structure in the universe formed, you need dark matter. If you don't put dark matter into your simulations, then you don't get a universe that looks like the one we live in. They need dark matter to make their theory work and to agree with what they allege that they see out there in the sky, and through techniques, through lensing and by looking at the rotations of stars around galaxies, they allege that they can calculate to a fairly high degree of confidence how much dark matter is out there, even though they can't see it. They give you pictures of a cosmic pie and have labeled everything. Everything seen when looking up at the sky. All the galaxies and stars and planets in the universe and everything the Standard Model describes is just 5% of the total content of the universe. They say 95% of the universe is made of invisible dark matter, and they don't know what it is. And they say 68% is something called dark energy, and they really don't know what that is. They say dark energy is some kind of mysterious repulsive force that appears to be causing the universe to expand at an ever-increasing rate. But they go on to say the lesson from this is essentially, when you hear the word dark in physics, to get very suspicious, because it basically means they don't know what they're talking about. I think it's the ether. So physicists have constructed what seems to be a stunningly successful theory over a century with clever experiments and theories. Then you realize that what they've been describing is a tiny fraction of the total content of the universe. They have a theory that works really well in the very narrow domain in which they've applied it, but tells us nothing about 95% of existence. That's a huge omission in the Standard Model. Another problem, besides science claiming to not know what 95% of the universe is, has to do with something called antimatter. All the matter fields, such as quarks, electrons, and neutrinos, for each of those particles or fields, there is a mirror image field, science says. Science claims that this has long been known, since it was discovered and predicted by Paul Dirac, and then discovered in experiments shortly afterwards. Each mirror image field retains all the properties exactly the same, but the electric charge is the other way around. For example, the electron, which is negatively charged, has a positively charged version called the positron, or the anti-electron. Muons, or muons, have anti-muons. The up quark has the anti-up quark. There's the anti-down quark, and etc. These are also part of the Standard Model. These things they claim exist and can be created very reliably in experiments where their properties are studied. Science claims to know they are out there and says they are indistinguishable from the matter fields except for their charges being the other way around. This is a problem, because if they apply this kind of understanding of matter, antimatter, to the formation of the universe, then this is what happens. This is what they say. They say at the Big Bang there's a huge amount of energy. That energy is converted into matter and antimatter. In the Standard Model, whenever you make a matter particle field, you also have to make the corresponding antimatter particle/field. If science makes an electron, they also make it with the positron. All these fields, anti-fields, being created at the same time, they're being created, they bump into each other and annihilate and turn back into light.